Okay, here in these problems we're being asked to simplify again. We have x to the third divided by x to the third. So the comment I want to make is that if you were to do this problem the long way, and you can always do this, which is the expanding way, x to the third really means you're multiplying x 3 times above. On the bottom you're multiplying x 3 times as well if you expand the top and expand the bottom. So if you divide x by x, divide x by x, divide x by x, every time you're dividing you're getting a 1. So the correct answer to this is 1. X to the third divided by x to the third is 1. Much like 5 divided by 5 is 1. Anything divided by itself is 1, with the exception of 0. The way we'd like for you to do it later on is to use the rule, and the rule would state keep the base the same, but subtract the exponents. 3 minus 3. That would mean that x to the power of 0 would be your answer. And you see we have x to the power of 0 right there in the bottom, and later on we're going to see a rule that says anything to the power of 0 is really 1. Our next problem, we have b to the ninth x to the third divided by b to the fifth x to the fourth. So the long way to do this would be to expand all your b's and x's in the top and on the bottom. The easier way that I'd like for you to do it is just to recognize that in this particular case you have 5 b's in the bottom, 9 b's in the top. So you're really going to subtract with the b's like that. What I'm saying is 5 of the b's in the bottom are going to cancel 5 of the b's in the top. So that's going to leave you with 4 b's being multiplied, or b to the fourth power. On the other hand, if you look at the x's, you have x to the third on top, which basically means x times x times x. On the bottom you have x to the fourth, which is x 4 times. So what we're going to have on the bottom is this. And I'll explain and show more depth in a little bit. Our final answer to this will be b to the fourth power over x. X to the first power, but it's understood. When you have just an x, it's understood to be x to the first power. This is our final answer. What I want you to recognize when you see a division problem like this is that when things divide themselves, it's always going to be a 1. So things will cancel, if you want to use the word cancel. So we have 9 b's on top, 5 b's in the bottom. After you cancel several of the b's, there's 4 b's left on the top, which is why in our answer we have b to the fourth. We have 3 x's in the top divided, and we have 4 x's in the bottom. 3 of the x's from the top are going to cancel 3 of the x's on the bottom. That's going to leave me with 1 x on the bottom in the denominator. That's why I have it there. I'd rather you think of it like that than to be overwhelmed with rules here and to say, why did he do 4 minus 3 on the bottom instead of 3 minus 4 on the top? Because my math lab might do 3 minus 4. I'm simply giving you the easier way. Subtract wherever there's more, subtract the others, because that's what's going to cancel out. Long way to do this problem, multiply b, expand the problem. B to the ninth means you have 9 b's in the top, and expand x to the third, which is x times x times x. On the bottom you have 3 b's and 4 x's being multiplied. And if you do this, I'm sorry, I didn't see my own writing. It's 5 b's on the bottom. So if you do that, there's 4 b's left on the top, and if you do this, there's 1 x left on the bottom. Final problem says, what is x to the 0 power? I kind of mentioned it right here. We're going to see this rule shortly. Anything to the power of 0 is actually a 1. Please remember that. We'll see a few more problems like that.